Okay, today is called 7.3, day 1, and you're going to learn to do what's called completing the square. All right, and to go from factored form to general form, you just generally multiply it out. To go from general form to factored form, you just factor it. That was pretty simple. To go from vertex form to general form, generally you just have to multiply out to get general form, right? But today you're going to be going from general to vertex form. So that means it starts out looking something like this. And that's general form. And we're going to get it to something like this. Do not write this down. This is just an example for you to see what vertex form looks like. Actually, there would be still a 3 in front, right? And then this would be like x plus 2 squared minus 1, that kind of thing. All right? This form, general form, to this form, vertex form. Does that make sense to you? That's our goal. Okay. Now, let's see if we can teach you how to do this as effectively as possible. First, that's general, or no, that's factored form. Right away, you can get the what's out of that. The zeros, the roots. Okay, and that's -5 and 3. True? Okay. Those are the X intercepts also, right? There's 4 things that they're called. Would you write down the 4 words for those? See if you can remember all 4 things that you're finding. Because that's the most important thing about quadratics, is that we can use these ways of solving them to get the roots, etc. While you're waiting for your iPad to wake up, grab paper. Okay? You got paper? Excellent. All right. Miss H, tell me one of the 4 things. X in. Excellent. Miss P in the front row, give me one. Roots. Wait a minute, you say roots? Does anybody in here say roots? All right, so it's roots or roots? Which one is right? It's just it's an opinion thing, okay? But let me ask you this one. I bet you'd be surprised at how many people say this differently. Okay? I want you to think the word that I'm about to say. I'm just going to describe it, and you think what you would say, and then I want you to all say it at the same time in a second. Okay? If you were going to go home and look up on that thing that's over the top of your house, and like the snow is gathering up there right now, and you're going to climb up on the roof. Is it a roof or is it a roof? How many of you guys are roof people? How many are roof people? See, it's like half and half, and we all live in Minnesota. Isn't that interesting? And how about this? If you're going to go pull up a plant by the what's? And I wonder if there's a correlation, if you're a root person, if you're also a roof person. And if you're a root person, are you also a roof person? I don't know. It's just one of those little dumb things about the way we say things. All right. And it's a kind of a big deal for people that are on TV, because if you sound too southern, they don't want to put you on the air because, people can't relate to you as well. Unless you are way down south, in which case they actually probably want people on there that have the local accent. So anyway, I'm just curious what they would consider the proper way to say roots in Minnesota, whether it's roots or roots. I'm guessing more. How many go with roots? How many are root people? Keep your hand up. I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 go with roots. And how many of you are then a root? You're pretty sure you'd say root people. 1, 2, 3, 4, 5, 6, 7, 8. I think I'm one of those. That would make 9 of us. All right, anyway. So you root people win, I guess. All right, then let's go to one more. DM. Give me another one. Zeros. Thankfully, I think there's only one way to say that. 0. I have heard people say a really weird version, but it's really rare. And what's the one that's missing? Steps with an S, yes? What did you think it was? Yes, solutions is correct. All right, so it does not matter which one you use unless you're saying on the graph you see where it's touching the x-axis, then you're probably talking about the x-intercepts. And the roots, that's not used as much, but it means the exact same thing as this and this, so you can use it if you want. The zeros is pretty easy. If you're trying to make this equation equal 0, it makes more sense that this -5 is a 0 because you're trying to make the equation equal 0. And why are we making it equal 0? Because we're finding the x-intercepts. The x-intercepts are where y equals 0. Remember that little saying? The x-intercept is where y equals 0. And the y-intercept is where x equals 0. Okay, good. Let's move on. Put this equation in general form. All right, everybody multiply that puppy out. First outside, inside, last. All right. First, and then outside and inside would make -6x and -3x totals -9x. And the last makes +9. Raise your hand if you had that one right. Okay, good. Now, that's in general form. Which of these is better for graphing? Factored or general? If I said graph it right now, which one would you grab and use? Factored, because it'll tell you the zeros, the roots, okay? Because I can find out, and by the way, that answer is not 3. So many people did that on the test. It's very frustrating. It's 2x minus 3 equals 0. 2x equals 3. X equals 3 halves, also known as 1 1/2. That answer that makes that 0 is 1 1/2. That answer is +3. And I think a lot of people just think, oh, it's always the opposite of that number. No, it's not. It's making this little thing into an equation and solving it. Okay. So I just found one of the zeros here, and the other zero is x equals 3. So that's a reminder on how to do that. And what did you do to put it into general? Generally, you just multiply it out to do that. Okay. So I want you to do this one completely yourself, and you're going to factor it. And it's reminding you what to look for first so you don't spend forever trying to factor this. I'll pause for a second while you try that. All right. Mr. M in the back row. Give me something that went into everything. 3. 3 comes out, and you'd have 5x squared minus 6x minus 3 goes into 8 times. Awesome. How many of you started that way? Good. Then MM, tell me what to do next. Did you use 2 sets of parentheses? Yep. Good. And all right, now let's see if you're right. It's pretty easy to tell. I do my first, that times that, and it makes that. Good. Then I do my outside and my inside, and that makes -10, and +4 makes -6x. And the lasts make -8. You are so right. Raise your hand if you had that one right. Okay, good. That is pretty tough factoring. Now, why did we factor it? Why does it help? Because we know the what from it? The zeros, the roots, the x-intercepts. We also know the stretch factor. It's kind of a nice thing to know, too. All right. So now let's get to this part where we're going to do from general to vertex form and do an example of that. It says to write these in factored form. Actually, I think it's okay to do one of these. Look at number 1, and there's something special about it. If you factor it, go ahead and factor it. I think you'll see something special about it. What'd you get? Yes. And +6. What's special about it is that they're identical. What happens when they are identical? You just put them right together. What would you have? What would you have then? Maybe you don't know this. squared. Then all of a sudden, we've got general form and factored form and vertex form all at the same time. You might say, wait a minute, that's not vertex form. I just put a plus 0 here. The vertex is negative 6 comma 0. See? I just have to throw a plus 0 at the end to make it look more like vertex form, and it is. Okay, so that's a real special kind. That is called a perfect square, because this and this were exactly the same thing as each other. Do that other one, and I bet you, since you know the topic I'm on, it's going to be really easy. Mr. M, you already got it? What is it? Yeah. Because the two negatives make a positive 49, and yet they make a middle term of negative 14x. Okay, good. And then that makes just the same idea, except with a minus in the middle. There we go. So that's called a perfect square again. The perfect square has these factors the same. Now, why is that important? Because we need that perfect square. All of these, this kind of problem here has got perfect squares. We need that perfect square to get vertex form. Do you get how all these are in vertex form? If I just put a plus 0 at the end of them, they're all in vertex form. So we are going to count on that perfect square thing. What would the last term have to be in order for this to be a perfect square? In other words, to make it work out really nice where they're identical to each other, what number would you need right there? Just say it if you know it. 25. Do you know a fast way to get that answer? All right, let's take it another one. What number should be right here to make it work? If you know it, say it. 9. Anybody notice a pattern? A way you could get that answer really quick? Okay, how about this one? Anybody know it? It's 4. Catch the pattern? Yes. Divide this by 2, which will be 5, and then you square it. 25. Divide that by 2, negative 3, and then you square it. 9. Divide that by 2, and you square it. And so instead of saying dividing by 2 and then square it, we have a shortcut name for this. Half and square. Half and square. Okay? So half and square it. So if I, for instance, give you y equals, no, let's make it simple to begin with here. X squared plus 6x, I know how to complete it. I just take half the 6 and then I square it. So what would it be? 9. What if I make this a 16x? And what are we doing this for again? Because now this thing will factor perfect. What'll it be? X plus 8 and x plus 8. Perfect square, meaning these are the same, right? All right. So then I ask you, why isn't this a perfect square? Because that last number should be a what? Should be a 9. So here's what we do. This is called completing the square. We say, well, it would be awesome if this number right there was a 9. So we just move the plus 3 over. Have I changed my equation at all except leaving myself a gap? No. So now, if I want to put a plus 9 here, do you get that normally you add 9 on both sides? If I add 9 to both sides, that's legal, right? But it's also legal if you add 9 and then immediately subtract 9 right away. Would you agree that you can do that? You can add 9 and subtract 9 right away and you've still not broken the laws of math? Let me give you an example. If 5 equals 5 and then I add 9 and then I subtract 9, isn't it true that I still have a true equation? Okay, so that's what you do. Why would you do that? Because now this part factors perfectly. And I just put these two together to get the other part of my vertex. Let's do this part. What does that factor to? x plus 3 and x plus 3. And then this part becomes minus 6. And why is that special? Because then these two can go together because they're the same. And there we go. And now that's a really fast way to find the vertex. Why is that handy? Because it's the most important point on a quadratic. It's the one spot where it changes from going down to going up. Or if you're going up, it's where it peaks and then starts going down again. It's the maximum or the minimum. It's also the high spot, the low spot in your graph. I mean, it's like really, really important. So that's why we spend some time learning this technique. All right, let me show you another one like that. Y equals, again, we can't have a lead coefficient because it's really much more complicated. But if I go x squared plus 2x, and if I had my choice, what would I want next? Half of the 2, and then you square it. Half of the 2 is 1, and then you square it as 1. It would be ideal if that was 1, but what if it's not? What if it's 7? Then you just move that 7 over. Say, I got to keep that 7 in the equation, right? I can't just get rid of it. It wouldn't be balanced anymore. But I can move it over, and then I can say plus 1 and minus 1. And this part right here is perfect. Go ahead, finish it off. Tell me what the answer is then. Turn it my way, and I'll tell you if you got it right. Yes. You'll have vertex form on your screen. Yes, yes. Get them together, the x plus 1s. Yes, 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 yes. Oh, your number, I think you didn't add the 7 to the negative 1. Get that together at the end. Yes. Put a y equals in the front of it. Yes. Yes. Put a y equals and you'll have it. Yes, 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 bad glare. Over a little further. Yes. Okay, good. Didn't get everybody. Yes, yes, yes. Okay. But almost everybody. X plus 1 and x plus 1. And you'll learn eventually that you can just write that right away as x plus 1 squared. And then this part right here, plus 6. So you can jump right to x plus 1 squared plus 6. Now let's see if you can do one all by yourself. What if I have y equals x squared plus 8x minus 9? That's not going to factor perfectly. So do what I just showed you. Make it a perfect square by completing the square. CTSFV. What the heck does that mean? I want somebody to figure out what that means in the next 15 minutes. Just let your subconscious work on it. CTSFV. All right. So now I'm going to take this 9, I'm going to move it over. And now I'm going to take half the 8 and then square it. Half the 8 is 4, and I square it, makes 4 squared is 16. If I add 16, I got to subtract 16 to keep my equation balanced. Otherwise, you can't just go around adding 16 to one side of an equation. All right. This part is the perfect square, and I will have x plus 8 and x plus 8. True or false? False, because 8 times 8 doesn't make 16. It's a really common mistake. Really, it was x plus 4 and 4, and then that makes, really, you could just jump right to x plus 4 squared, and then this part goes together, negative 25, and I have completed the square, and now I have found the vertex. Okay, what is the vertex in this one? Close. -4, -25. There we go. There's the vertex. All right. Anybody figured out what CTSFV is? Yes? Complete the square for vertex. Yes. Now, why am I reminding you of that? Because everybody forgets what we're doing completing the square for. And so they'll ask on a test, they'll say, find the vertex. And people will be like, well, I don't know what gives you the vertex. And so I'm trying to give you a way. CTSFV. That's going to be my little shortcut. Go ahead and CTSFV this one. I wish it was shorter, but it's a lot of words. Complete the square for vertex. Now, I could make up a new name for it, but the bad part about that is when you go to next year, they're going to call it completing the square again. You have to know this is completing the square. CTSFV. Because I want to make it complete the square for the vertex. That's what you're doing it for. Hopefully you knew enough to first just move the +5 over, then take half of this and square it. Half of 10 is 5, actually it's -5, and then you square it, and that's going to make it positive anyway. +25. Do you notice that number is always going to be positive? It's always going to be plus. Think about it. You're squaring something to get it. Therefore, it's always going to be a plus. Always, always. Okay. And then I go a -25 to keep it balanced. And then this part is your perfect square. You should have said x plus 5 squared. I'm making a mistake on purpose here. -20. If you said that, you really were really close, but you missed something. Who knows what I missed? Only 3 people. N, A in the back row. Yes, this should be a -5 in there. Why? Because I have a -10x in here. And if you did a plus, this equation would only have pluses in it, and there'd be no way to get a minus. So be careful with that. All right. So there we go. And now we did CTSFV because what's the FV part? What's it stand for? For the vertex. Because we did this because we wanted the vertex. What's the vertex then? Come on, do this right. Oh, is it? Shoot. I got all confused with which one it was. You're right, it's -5 in there. So now, what's the final answer? 5, -20. There we go. That's my vertex. Okay, next thought. Does this one have a stretch factor? No, if it did have a stretch factor, it'd be like right here, right? So let me show you how that would look. Oh, wait. Yeah, actually, that's right. Now, normally, would you agree on this? I would say, okay, look to see if anything factors out of everything. And you say, okay, 3 goes into the first one, 3 goes into the second one, but a 3 doesn't go into the third one, so I can't factor it. But actually, we've been lying to you over all these years. You can factor that. You can factor a 3 out of that. How can you factor it out without including the 1? Just factor a 3 out of these two. Let me show you what it looks like then. Y equals 3 comes out of these two, and I have what left? X squared plus 2x plus 1. Okay, now why would I want to do that? Because I need that stretch factor out front. Now you act like that 3 doesn't even exist. And you do the rest of this problem the same way as before. This plus 1, I need to slide it over to make room. I got to do my half and square thing. Half the 2x is what? 1. And then half the, sorry, I shouldn't do half the 2x. I should do half the 2 is 1. And then I square it is 1. And if I put a plus 1 here, I got to put a minus 1 there. And wait a minute. That plus 1 would have been okay in the first place, wouldn't it? Wouldn't this 1 have been okay in the first place? Wasn't there a plus 1 here? Yes. Exactly. All of a sudden now this 3 that I factored out would have to multiply by that. So you're correct. I had to move that plus 1 over. Okay. So you got to follow the process. So I move that over. I figure out half of this and I square it. It's just a plus 1 and a minus 1. And now this is an important part here. I think you know that this part here will factor and be a perfect square. So we have done something wrong, and I am not showing you what it is yet. So the 3 comes out, and then I have x plus 1 and x plus 1, and then this minus 1 and plus 1 will be plus 0. And then this would be y equals 3, and then x plus 1 quantity squared plus 0. And this is a really common mistake. Answer. You're all going to do it. Seriously. I just did it on purpose, and I'm just going to show you where I made the mistake. All right. Now, you tell me, when I did this plus 1 and this minus 1, why was I doing that again? Why did I do a plus 1 and a minus 1? Yes. So they cancel each other out. That's messed up in this problem. Why? Because of the 3. This 3 is going to multiply by that 1 and make it 3 times as big. So this is supposed to cancel that out, but it's not going to be big enough to cancel that out. So we have to multiply this one also by that 3. And that is the hard part. Now, honestly, many of you are not ready for that yet, and you probably can't handle that. But I'm teaching you 2 lessons at once today. I could have stopped a minute ago and not done this factoring out part, but I'm trying to go a little further into it because that's tomorrow's lesson. It's like foreshadowing in a book. Okay? So all I really need you to do for today's homework, and by the way, tomorrow is that plan test, I think it's called, and a lot of you guys won't be here because we're taking that plan. In fact, I don't think anybody in this class will be here tomorrow. Okay? So, or is it this? Okay, hold on. I'm going to pause for a second, figure out which class I'm in. Okay, so this foreshadowing thing, let me finish off how to do this problem right so that those of you that miss tomorrow, you've kind of got a little bit of the lesson. So you don't have to, it's not going to be as stressful for you when you miss the lesson tomorrow. So y equals this 3 times the negative 1 part here is the only part I need to do different. So this is still 3, and this is still 2 sets of parentheses that are identical, x plus 1 and x plus 1. And down here I have 3 times negative 1. That's all I got to do different. That's negative 3. Negative 3 plus the 1. Negative 3 plus 1 makes negative 2. And now why isn't it in perfect square form? Just because that and that haven't gone together yet. Y equals 3x plus 1. Now it's in vertex form. That's what I was doing. CTSVF. Complete the square for vertex. Actually, FV, sorry. FV. Just trying that out myself. Complete the square for vertex form. And the vertex in the end was negative 1 comma negative 2. And it had a stretch factor of 3. All right. So your homework for tonight, I'd like to open that up and get started on it together. And then for those that are gone tomorrow, you've had a little bit of a mini lesson at the end there, how to do it. But if you want to watch the video for that, you'll be able to stay all caught up. All right. So let's get to the worksheet. I'll pause for a second while Okay, first part of the homework is a lot of factoring, and frankly, I think you're pretty good at that in my class anyway, so I'm going to let you skip C and D on those 2. Let's move down to number 2. This is just what number do you need to complete the square. If you catch on to half and square, this part will be really super easy, so I don't even need to cut it down. Take you more time to cut it down than just do it. So now I go to part 3. Part 3 is actually completing the square. So here, in case you can't see it at home, it says y equals x squared minus 6x plus 5. And what's wrong with it? That number's not right. So I move it over, and I say plus 5 goes to the end here. And in here, I squeeze in 2 numbers, the opposites of each other. So the, half of negative 6, and then I square it. Half of negative 6 is negative 3, and then I square it, makes positive 9. Notice that'll always be positive there. And then if I do a plus 9, I got to do minus 9 to balance it out. And now this part is my perfect square part. That's why I was completing a square, because now it's a perfect square. And then the negative 9 and the 5 will go together at the end. See if you can finish it off. KK, K squared. What do you got for this one? Don't have it yet? All right. I'm calling somebody else. I'll come back to you on a different one. Who haven't I picked on in a while? I think I can go with Mr. R. Oh, come on. All right. Fine. I'll do this one. Negative 4. And then this one must be x and an x. And then, oh, I got to have a minus to make this negative in there. So minus 3 and minus 3. Then I think I've got x minus 3 squared minus 4. Can anybody verify that? All right, good. So that's called completing the square for the vertex. If you even just remember that there is an acronym, it might remind you that there's some reason why we're doing it. So you might be asked the test question, why are we doing complete the square? And you'll have to be able to say, so that we can get the vertex. Or they might ask you the question, find vertex form. And I'm hoping that this connects vertex form with completing the square for you. Okay, now I'm looking at this worksheet, making sure that it's not like unreasonably large. It's really not. They do ask you to graph an awful lot of them though. So considering you guys are already pretty good at graphing, I'm going to say you can skip the last 4 graphs. And that's cutting it down because we had kind of a long lesson today. And I want you to have time to get your homework partially done before you leave and not too much left at home. All right, that's all I have for you for today. Okay, one more good point somebody brought up was what happens on D when you have a whole number like 5 and you're supposed to do half and square? What's half of 5? I would go with 5 over 2. That's half of 5. And then, yes, you could say it's 2.5, but I'm telling you, you decimal people will pay a price in the end because you're going to have to do nasty decimals if you want to do decimals. Fractions are actually easier. It's actually true. Half of 5 is 5 over 2, and then I have to square it. Do you get how squaring that's actually very easy? So it's 25 over 4. That's your answer, 25/4. As opposed to the people who decide, I'm going to be stubborn and use decimals because I like decimals. Well, yeah, how much do you like them now? You got to square 2.5. You got to go 2.5 times 2.5. And if you wanted to do that, go ahead, but have a lot of fun when it turns out to be 1.75 and you got to square that. Okay, it'd be a lot easier to use the fractions. I'm telling you. Okay, so when you do half and square and it's not a nice number, just use a fraction and then square it. Have a good day.